In a brewery bottling production line, three-phase squirrel-cage induction motors are commonly used. The horsepower rating of induction motors used in brewery bottling production varies depending on the specific application and the size of the brewery. However, typical horsepower ratings include for conveyor belts 1 to 5 horsepower, for bottle fillers 10 to 25 horsepower, for labelers 5 to 15 horsepower, for depalletizers 20 to 50 horsepower, and for palletizers 20 to 50 horsepower. Capacitors are used in induction motors to improve starting torque and power factor. The maximum range of capacitors used typically depends on the motor size and application. However, typical values for brewery bottling production applications include for starting capacitors 50 to 250 microfarads, and for run capacitors 10 to 50 microfarads. Variable frequency drives are also commonly used in brewery bottling production to control the speed and torque of induction motors. Special purpose motors, such as explosion-proof or washdown duty motors, may be required in certain areas of the brewery. A good understanding of induction motor principles and electrical codes is essential for maintenance personnel in brewery bottling production. Induction motors are widely used in various industrial applications due to their reliability, efficiency, and relatively low cost. They operate on the principle of electromagnetic induction, where a rotating magnetic field in the stator induces a current in the rotor, causing it to rotate. The squirrel-cage design is a popular choice because of its simplicity and robustness. The three-phase power supply creates a rotating magnetic field in the stator windings. This rotating field induces current in the rotor bars, which are shorted together, creating a magnetic field in the rotor. The interaction between the stator and rotor magnetic fields produces torque, causing the rotor to rotate. The speed of the motor is determined by the frequency of the power supply and the number of poles in the motor. Horsepower is a unit of power that measures the rate at which work is done. In the context of induction motors, horsepower indicates the motor's ability to deliver torque at a certain speed. The horsepower rating of a motor is determined by the load it is intended to drive. In a brewery bottling production line, different components require different horsepower ratings. Conveyor belts, which transport bottles and materials, typically require smaller motors with horsepower ratings ranging from 1 to 5 horsepower. These motors need to provide consistent torque to move the belts at a steady pace. Bottle fillers, which accurately dispense liquid into bottles, require more powerful motors with horsepower ratings ranging from 10 to 25 horsepower. These motors need to handle the precise control of filling mechanisms and maintain consistent filling speeds. Labelers, which apply labels to bottles, require motors with horsepower ratings ranging from 5 to 15 horsepower. These motors need to provide accurate and reliable label application at high speeds. The palletizers, which remove bottles from pallets, and palletizers, which stack bottles onto pallets, require the most powerful motors with horsepower ratings ranging from 20 to 50 horsepower. These motors need to handle the heavy lifting and precise movements involved in palletizing and depalletizing processes. Capacitors are electrical components that store electrical energy. In induction motors, capacitors are used to improve the motor's performance in two key areas: starting torque and power factor. Starting torque is the torque produced by the motor when it starts from rest. Some applications require a high starting torque to overcome inertia and get the motor running quickly. Capacitors can be used to increase the starting torque of an induction motor by providing an extra boost of current to the motor windings during startup. Run capacitors, on the other hand, are used to improve the power factor of the motor during continuous operation. Power factor is a measure of how efficiently the motor uses electrical power. A low power factor indicates that the motor is drawing more current than necessary, which can lead to increased energy consumption and higher electricity bills. Run capacitors help to correct the power factor by reducing the amount of reactive power drawn by the motor. The size of the capacitors used in an induction motor depends on the motor's size, voltage, and application. Starting capacitors typically have higher capacitance values than run capacitors. Typical values for starting capacitors in brewery bottling production applications range from 50 to 250 microfarads. Typical values for run capacitors in brewery bottling production applications range from 10 to 50 microfarads. Variable frequency drivers are electronic devices that control the speed of an induction motor by varying the frequency of the power supply. VFD offers several benefits in brewery bottling production applications. Firstly, they allow for precise control of motor speed, which can be used to optimize production rates and improve efficiency. Secondly, they can reduce energy consumption by matching the motor speed to the actual load requirements. Thirdly, they can provide soft starting capabilities, which reduce the stress on the motor and driven equipment during startup. Special purpose motors are designed for specific environments or applications. In a brewery, certain areas may require explosion-proof motors to prevent ignition of flammable substances such as alcohol vapors. These motors are designed with enclosures that can contain an internal explosion without causing an external hazard. Other areas may require washdown duty motors, which are designed to withstand frequent cleaning and sanitizing. These motors are typically made with corrosion-resistant materials and sealed to prevent water ingress. Induction motor principles and electrical codes are essential knowledge for maintenance personnel in brewery bottling production. Understanding the principles of operation of induction motors is crucial for troubleshooting problems and performing maintenance tasks effectively. Electrical codes, such as the National Electrical Code in the United States, provide guidelines for the safe installation and operation of electrical equipment. Adhering to these codes is essential to prevent electrical hazards and ensure the safety of personnel. Maintenance personnel should be familiar with the relevant codes and standards for induction motors, wiring, and grounding. They should also be proficient in using electrical test equipment, such as multimeters and insulation testers, to diagnose problems and verify the integrity of electrical systems. Regular maintenance of induction motors is essential to ensure their reliable operation and prolong their lifespan. Maintenance tasks include lubricating bearings, inspecting windings for damage, cleaning motor enclosures, and testing insulation resistance. Proper maintenance can prevent costly downtime and extend the life of induction motors. Induction motors are essential components of brewery bottling production lines. Understanding their types, horsepower ratings, capacitor requirements, and control methods is crucial for ensuring efficient and reliable operation. Maintenance personnel should possess a solid understanding of induction motor principles and electrical codes to perform their duties effectively and safely. Remember to always consult with qualified professionals and refer to relevant codes and standards when working with electrical equipment. Brewery bottling production lines employ a variety of equipment driven by induction motors. The selection of the appropriate motor type and horsepower rating is critical for ensuring efficient and reliable operation. The three-phase squirrel-cage induction motor is a common choice due to its robust design, ease of maintenance, and relatively low cost. The horsepower rating of the motor must be sufficient to handle the load requirements of the driven equipment. Oversizing the motor can lead to inefficiency, while undersizing can result in overheating and premature failure. The selection of the appropriate capacitor size is also important for optimizing motor performance. Starting capacitors provide a boost of torque during startup, while run capacitors improve the power factor during continuous operation. The correct capacitor size depends on the motor's characteristics and the load requirement. Variable frequency drives offer a versatile means of controlling the speed and torque of induction motors. They allow for precise adjustment of motor speed to match the process requirements, resulting in energy savings and improved control. VFD also provides soft starting capabilities, reducing stress on the motor and driven equipment. Special purpose motors, such as explosion-proof and washdown duty motors, are required in certain areas of the brewery to meet safety and hygiene standards. Explosion-proof motors are designed to prevent ignition of flammable substances, while washdown duty motors are designed to withstand frequent cleaning and sanitizing. Maintenance personnel play a crucial role in ensuring the reliable operation of induction motors in brewery bottling production lines. Regular inspections, lubrication, and testing are essential for preventing failures and extending motor lifespan. A thorough understanding of induction motor principles, electrical codes, and safety procedures is essential for maintenance personnel. In addition to the basic types of induction motors, there are also specialized designs for specific applications. For example, servo motors are used in high-precision motion control systems, while gear motors combine a motor with a gearbox to provide high torque at low speeds. The choice of motor type depends on the specific requirements of the application. The efficiency of an induction motor is an important factor to consider when selecting a motor. Higher efficiency motors consume less energy and reduce operating costs. Motor efficiency is typically expressed as a percentage, with higher percentages indicating greater efficiency. Energy-efficient motors may have a higher initial cost, but they can pay for themselves over time through reduced energy consumption. The operating temperature of an induction motor is another important factor to consider. Excessive heat can damage the motor windings and reduce its lifespan. Motor manufacturers typically specify a maximum operating temperature for their motors. Cooling fans and other cooling methods can be used to keep the motor temperature within acceptable limits. The insulation resistance of an induction motor is a measure of the integrity of the motor windings. Low insulation resistance can indicate damage to the windings and increase the risk of electrical breakdown. Insulation resistance testers are used to measure the insulation resistance of motors. Regular testing of insulation resistance can help to detect potential problems early on. The bearings of an induction motor are critical for smooth and reliable operation. Worn or damaged bearings can cause excessive noise, vibration, and heat. Bearing lubrication is essential for maintaining bearing health and extending bearing lifespan. Different types of bearings require different types of lubricants. The motor's nameplate provides important information about the motor's characteristics such as horsepower, voltage, current, speed, and frequency. The nameplate also includes information about the motor's insulation class, which indicates the maximum operating temperature of the motor windings. The nameplate is a valuable resource for maintenance personnel. Troubleshooting induction motor problems requires a systematic approach. Common problems include overheating, excessive noise, vibration, and failure to start. A multimeter can be used to measure voltage, current, and resistance to diagnose electrical problems. An insulation resistance tester can be used to check the integrity of the motor windings. A vibration analyzer can be used to identify the source of vibration problems. Repairing induction motors can be a complex and specialized task. Minor repairs, such as replacing bearings or brushes, can be performed by qualified maintenance personnel. Major repairs, such as rewinding the motor windings, typically require specialized equipment and expertise. It is important to follow proper safety procedures when working on electrical equipment. Always disconnect power before performing any maintenance or repair work. Use appropriate personal protective equipment, such as gloves, safety glasses, and hearing protection. Be aware of potential hazards, such as electrical shock and moving parts. Induction motors are an integral part of brewery bottling production lines. Understanding their operation, maintenance, and troubleshooting is essential for ensuring efficient and reliable production. By following proper procedures and guidelines, maintenance personnel can keep induction motors running smoothly and safely. The advancements in motor technology continue to improve the performance and efficiency of induction motors. New materials, designs, and control methods are being developed to reduce energy consumption, increase reliability, and extend motor lifespan. Staying up to date on the latest advancements in motor technology can help to optimize the performance of brewery bottling production lines. From motor selection to maintenance practices, a comprehensive understanding of induction motors is crucial for success in the brewery industry. By investing in training and resources, breweries can ensure that their maintenance personnel are well equipped to handle the challenges of maintaining these essential pieces of equipment. Remember to always prioritize safety and follow proper procedures when working with electrical equipment. Consult with qualified professionals and refer to relevant codes and standards to ensure a safe and efficient working environment. With proper care and attention, induction motors can provide years of reliable service in brewery bottling production lines. The information provided here serves as a general overview of induction motors in brewery bottling production. Specific applications and equipment may have unique requirements and considerations. Always consult with the equipment manufacturer and qualified professionals for specific recommendations.